Alright guys, welcome to this set of videos which are going to follow along with the notes out of your textbook from Chapter 2, Section 4. And what we're going to be doing in this set of notes in these video lessons is taking a look at writing linear functions. Now, as we go through these notes on this set of videos, I have two objectives for you, sort of learning targets, things that you should be able to do by the time we get to the end of these videos and this set of notes. Let me highlight them for you as we go through them. The first thing you're going to need to be able to do is write an equation of a line given the slope and a point on the line. So you'll need to be able to write an equation if you're given the slope and a point. So watch out for that as we go through these problems. When we get to those types of problems, make sure you're paying attention, following along, and you know how to do that when we get to the end. The second objective or learning target for you is going to be writing the equation of a line parallel or perpendicular to a line that you've already been given. You would have looked at this both in Algebra 1 and again in geometry, writing the equations of parallel and perpendicular lines. So we're going to practice those as well here. Now, the first thing I'm going to do for you guys here on this page of the notes to kind of jump into this, one of the equations that we're going to use extensively now in this section here in Section 4 of Chapter 2 is going to be the slope-intercept equation for a line. Now, the slope-intercept equation for a line, you know, is y equals mx plus b. Y equals mx plus b. But I want you to see where it comes from. So let's go ahead and take a look at how that equation is derived. What I've got for you is a graph, and I've just drawn a line on the graph. Now remember, we are finding the slope-intercept form of a line. What that means is that I need two points, and one of those points needs to be the intercept. So all I do is whatever line I've drawn, I just simply select the point where that line crosses the y-axis. And I'm going to label that point 0, because the x value is 0, b, which is my y-intercept. And remember, in the equation, y equals mx plus b, b of course being the y-intercept. So that shouldn't come as any surprise to you why I labeled a point that way. Then what I need is a second point. You can choose that point to be anywhere. It could be a point over here, it could be a point right here, it could be the point I've chosen right here, and we're simply going to call that point x comma y for the x value and the y value. Now here's how this is going to work. I'm going to go ahead and use my equation for the slope. Let me slide this up just a little bit further. There we go. Now what's going to happen here is I'm going to plug stuff into my slope equation, y2 minus y1 over x2 minus x1, and that's exactly what I'm going to do. Here's my y2, so that goes in for y2. Here is my y1, so that goes in for y1. Here's my x2, so that goes in for x2, and here's my x1, so that goes in for x1. Now what I have is my slope equation written as y minus b all over x minus 0. Well, this is easy. Anytime you have something minus 0, you're going to get x. Alright, so what I've done is I've simply taken my slope equation, I have plugged in two generic points. One of those points must be the intercept. The other one doesn't matter, and you're going to get all the way to this. Now what I'm going to do in order for it to be an equation, we solve for y. So I need to get this y all by itself. Piece of cake. I have division by x, so I'm going to multiply both sides by x. There it is. I now have m times x is equal to y minus b. Okay, well, I need to get the y by itself, and since I have a negative b, let's add that guy to the other side. Now I have mx plus b is equal to y. We are almost there. Symmetric property lets me flip it, and we wind up with y is equal to mx plus b. And what you now see is where this equation, which we call the slope-intercept, slope-intercept form of a line comes from. It actually comes from, choose any line, and it comes right from the slope equation. right? Slope equation where one of my points was an intercept, and we work our way all the way down through the algebra leads you all the way to right here, the slope-intercept form of a line. Now that we know where it comes from, flip on over to the next page of the notes. We'll get started looking at some example problems. I'll meet you there.